Hi, and welcome back to VTC C++ Programming Fundamentals. We've been talking about various types of constructors here for a while, and now we want to talk about destructors. The destructors are the members of the class that takes care of cleanup when the class is no longer necessary and when objects in the class need to be gotten rid of. Now, there are destructors for everything, though you don't really have to deal with them. All of the base objects that are in the language have destructors for them, so that when you delete them or when an automatic goes out of scope, you know that it disappears, it gets pulled off the stack, it gets destroyed somehow. Well, a destructor is always responsible for doing that. When we create our own classes, though, we need to create sometimes our own destructors, because we might do interesting things in the construction of an object that has to be properly taken care of during the destruction of the object. We might get some file tokens open or locks, or we might acquire some memory in an array or something like that, and we need to properly clean that up. And we're the ones that created it, so we're the only ones that really know how to get rid of it. So again, the destructor is the function that is called when a class is no longer needed, or when that class object goes out of scope and it's no longer necessary to be in memory. Of course, when the entire program ends, anything that is still in scope and still functioning will have its destructors called so that it's gotten rid of. The destructor is identified by the tilde in front of the class name, so that makes it the complement to the constructor, because as you know from C programming, the tilde in the front there is the one's complement. So this is a complement to a constructor, a destructor. There is only one destructor for each class. It cannot take in any arguments, and it cannot give back any return values, because everything that it's doing is destroying things and throwing them away. So it has no structure to use to get anything back to you. Again, it cleans up everything created by the constructor. Now, you want to make sure that you don't exit while you're exiting, because when you're in a destructor, you're leaving the functionality of that object. You're getting rid of that object. So if you would call exit in there, exit by its definition calls the destructors. Well, now you're back in the destructor, and then you call exit again, and you're back in the destructor. See what's going to happen? You're going to wind up in a tight little loop there and get stuck. So just be careful that you don't do that on the way out. Let's take a look at a sample destructor here. This is pretty much our same little stub program that we looked at before, and it's when we were talking about constructors. And here we're going to have a class with a name, and here it's going to have the S character pointer in it, and a lot of other things will be created in here. So that's our name class. Now we have a table class, and a table class will have a name pointer to. So now we know that we have a pointer to one or more of these classes up here. And here we have a little SZ that's the size, and you're going to see that's the size of how many of these P pointers are actually out there. And here's our access descriptor for public. Says that this is publicly accessible. Below, this was private up here. So here's our table, and our default will be 15 elements in the table. It will be passed in to S. And here is the constructor for the table class. It's inline, so it's right there in the code. It's our open and closed brace. Remember, we can do that. Here we say that our pointer is equal to a new name array of this SZ size. And the S we know is 15 by default, unless somebody creates a table of a different size and they pass in a different value. If they don't pass us a value, we'll use this 15 for our default. So this is, in this constructor, it's doing something a little different, a little something interesting by creating this array. So we need to have the destructor understand that and know how to get rid of this thing when table is no longer in scope, when table can be thrown out. So there's our one's complement, or our little tilde to show that this is the destructor name. And remember, that was a constructor. It's the same name as the class. And here we have the same name as the class again, but with the tilde in front of it. This is our destructor. Again, it is an inline declaration and definition of this function. And all it's going to do is a one-liner delete of this array known as P. So that will go through and get rid of those objects that were created up here during construction. Now, who knows what we've been doing all the time with this thing after it got created, but now, as we're getting rid of it, as table is being deleted, C understands that it must do this delete function. And there's a couple of other functions in here. There's a name lookup that's a public member of the table class so that somebody could look up something in the table. And here's another one that's an insert, and they could put things into the table, and we'd probably have something else where they could delete things out of the table, but we don't care about that. This is what we're after right here. So that's the function of the destructor, is to get rid of the things that you created with the constructor. Very simple.